Everyone is talking about Chinese AI models. DeepSeek, Quen, Kimi, GLM, Minimax. Every few weeks, there seems to be another model claiming frontier level intelligence at a fraction of the price. And the usual story goes something like this. Chinese models are cheaper, many of them are open, you can run them locally, and they are quickly catching up with the most expensive American models, which sounds a fantastic deal. See, if one model charges 100 rupees for work and another model charges 500 rupees, why would any sensible business continue paying 500 rupees? But here is the problem with this comparison. The price shown on an API page is the price of generating tokens. It not necessarily the price of completing your work. A model can cost one-fifth as much and still become more expensive after you count failed attempts, human review, corrections, delays, and the infrastructure. And Chinese, cheap, open, local, and private are not five different ways of saying the same thing. A model can be cheap through an API but extremely expensive to run locally. It waits may be downloadable, but the license may still place restrictions on how you use them. It may be hosted by a US company even though the model was developed in China. Or it may run on your own server while its tools, logs, and telemetry continue sending data somewhere else. So the real question is not, are Chinese models good or bad? And it's not even, are Chinese models cheaper? The real question here is, can this exact model through this exact endpoint complete this specific job under an acceptable check I trust? And can it do that at a lower total cost? This is what we are going to unpack today. Namaskar friends, I am Dev and you are in my channel Talent Copilot, where we talk about AI and its impact on your business and on your personal lives. Let's begin. To start with, stop comparing countries and start comparing systems. When someone says Quen is good at coding, that statement is incomplete. Which Quen model? A small checkpoint running on a laptop? A large downloadable model hosted by a third party? Or Alibaba's own API? These products may share a family name, but they still can have different capabilities, costs, licenses, context windows, and privacy implications. The same applies to DeepSeek. Using DeepSeek through its official API is one system. Using its weight through another cloud provider is a completely different system. Running a smaller distilled version locally is another. And self-hosting a flagship model across multiple high-end GPUs is something else entirely. So don't evaluate a model family as one product. Evaluate three things: the job, the endpoint, and the check. The job is the exact result you need. Are you extracting fields from invoices, classifying support messages, modifying code, or asking for strategic advice? The endpoint is the exact service processing the request. Is it the developer's API, an independent cloud provider, a quantized checkpoint, or your own server? And the check is how you decide whether the result is acceptable. Can software verify the answer automatically? Can you run tests? Can you compare quotation with their original sources? Or must an expensive employee manually investigate every output? The final question often determines whether the cheaper model is actually cheaper. The real cost is the cost per accepted result. Imagine an Indian direct to customer company receives 10,000 customer messages every month, and it uses AI to classify each message: delivery issue, refund request, damaged product, product question, potential fraud, or something requiring a human agent. Its existing premium model costs 20,000 rupees a month. Then the company finds a cheaper model that can process the same number of messages for only 4,000 rupees. On the pricing page, that looks like a savings of massive 16,000 rupees. But after deployment, the team discovers that the cheaper model regularly confuses damaged item claims with normal returns. It also struggles with messages mixing English, Hindi, and regional language phrases. Employees now spend 80 hours every month reviewing and correcting the classifications. At an internal cost of 400 rupees per hour, that review itself costs 32,000 rupees. The supposedly cheaper system now costs 36,000 rupees, 4,000 for the model and 32,000 for the human repair. Suppose the premium model requires only 15 hours of review, it total cost becomes 26,000 rupees, 20,000 for the model and 6,000 for the review. These numbers are illustrative, but the principle here is extremely important. The cheaper model can become more expensive once its outputs enters a real workflow. That is why the better formula is total cost per accepted results. That equals model cost plus tools, retries, infrastructure, review and repair divided by number of outputs the business can actually use. An accepted result is not simply an answer the model generated. It is an answer that meets the instructions, follows the required format, contains no untraceable errors, and can move to the next stage without further repair. Here, we also need to measure the first attempt success separately from the eventual success. Two models may eventually complete 19 out of 20 tasks, but if one passes 18 tasks immediately, while other passes only 10 and need retries for the rest, they do not have the same operational cost. One is reliable. The other might be recoverable, but you are paying for more latency, more costs, and more points of failure. In May 2026, the US Center for AI Standards and Innovation, or CAISI, published an evaluation of DeepSeek V4 Pro. For the economic comparison, it used GPT 5.4 Mini as the American frontier reference model. DeepSeek V4 Pro was more cost efficient on 5 of the 7 benchmarks included in the comparison. But across those 7 benchmarks, its relative expense ranged from 53% lower to 41% higher. The same candidate model was significantly cheaper on some work and more expensive on other work. CAISI examined the end-to-end expense on problems that both models solved correctly, not merely their advertised price per million tokens. And that is the important lesson. There is no universal answer to whether a model is cheaper. Model economics are completely task dependent. Mixture of experts does not make a flagship model a laptop model. Now we need to address one technical idea that creates a lot of confusion. Mixture of experts. A mixture of experts model contains multiple specialized group of parameters called expert. For each token, a routing system activate only some of those experts instead of using the entire model. So think of it as a large hospital. The hospital might have 100 specialists, but one patient may need only a cardiologist, a radiologist, and a surgeon. You don't need all 100 doctors treating the same patient. That can make the treatment more efficient and more cost effective. But the hospital must still maintain access to the complete specialist team. The same distinction applies to an AI model. Active parameters and total parameters are not the same number. Take DeepSeek V3 and R1 for example. They have approximately 671 billion total parameters while activating around only 37 billion for each token. Activating only a portion can reduce the computation needed per token, but it does not mean the full system only needs to store 37 billion parameters. Different tokens may be sent to different experts, so the serving system still needs access to the complete collection of weights. Those weights must live in the GPU memory, system memory, or across multiple machines. Quantization can reduce the memory burden by storing weights at a lower precision, but a flagship model may still require hundreds of GBs of RAM along with additional memory for context caching and runtime overhead. I know many of you would be thinking of self-hosting as of now, but self-hosting introduces its own costs. GPUs, electricity or cloud instances, monitoring, authentication, security updates, engineering time, capacity planning, and you have ideal hardware when the demand is low. So mixture of experts can make inference more computationally efficient, but it will be wrong to say that you can have a giant flagship model like Kimi K3 practically on an ordinary laptop. You still need a chain of GPUs for that. Now, downloadable means you can obtain the weights. It does not mean that your business can operate them cheaply. Now, let us understand distillation and how it rapidly spreads the capability, which is another important part of the Chinese model conversation. In distillation, a powerful teacher model produces answers, examples, reasoning behavior, or preferences, and a smaller student model is then trained on that material. The student can inherit useful behavior without repeating the teacher's entire training process. DeepSeek did this openly with its own R1 model. It released 6 dense distilled models based on Quen and Llama architectures. Its repository says several Quen-based versions were fine-tuned using 8 lakh samples curated from DeepSeek R1. Those distilled models range from 1.5 billion to 70 billion parameters. But distillation does not squeeze the complete teacher into a smaller file. A student may perform extremely well on familiar patterns while losing the depth, adaptability, or reliability outside those patterns. That is why distilled models should be tested on messy cases, change instructions, missing evidences, conflicting constraints, and situations where the correct response is to stop. You need to know what happens when the task no longer resembles the examples the student learned from. Now to the spicy topic of distillation allegations. See, distillation itself is a normal technique. A company can distill its own model. It can also use another teacher when the license or agreement permits it. The controversy begins when outputs are allegedly obtained by violating service terms or evading access restrictions. In February 2026, Anthropic alleged that DeepSeek, Moonshoot, and Minimax used approximately 20,000 fraudulent accounts to generate more than 16 million exchanges with Claude. Anthropic described them as industrial scale campaigns intended to acquire capabilities involving coding, reasoning, tool use, and agent orchestration. These are Anthropic's allegations, not court findings, and they should be described that way only. But the strategic concern here is very clear. Advanced chips are physical objects. Access to them can be restricted. Model outputs, on the other hand, are piece of information. If useful reasoning and tool use behavior can be transferred through millions of generated examples, some capability may spread without every company recreating the original training process from zero. Here, the transfer does not have to be perfect to matter commercially. If enough useful behavior reaches a cheaper model, that model can become valuable across thousands of bounded tasks. This is also why businesses should retain their prompts, validators, and test cases. Today's best value model may not remain the best value model 6 months from now. If you own the evaluation system, you can retest new providers without rebuilding your workflow from scratch. Cheap, open, local, and private are separate decisions. We can now separate 4 claims that are frequently confused. Cheap means the completed, accepted result costs less. Open means the available weights and license that give you specific rights. You still need to read the exact license. Local means your hardware can operate that exact checkpoint at the speed and reliability you require. And private means you have traced where prompts, inference, logs, telemetry, and tool calls actually go. An open weight model may be too large for your machines. A cheap API may send sensitive information to an external provider. A locally running model may still call a cloud based search engine or analytics service. And the same model weights can create different privacy situations depending on who hosts them. For Indian businesses, handling client records, financial documents, or confidential company data, don't ask only which country developed the model. Ask which company receives the prompt. Where is it processed? What gets logged? How long is that information retained? Can it be used for training? And which external tools receive part of the request? The model nationality does not answer this question, the deployment part does. See, Chinese models also make economic sense in several cases. Chinese models are absolutely worth testing. In some workflows, they can create substantial savings. The strongest candidates are usually bounded, high volume, and checkable tasks like extracting predefined fields from documents, classifying messages, converting one known format into another, producing first pass research with mandatory source checks, generating software tests, making mechanical code changes from a precise specification, reviewing documents against a written checklist. These tasks repeat frequently, have a clearly defined result, and allow mistakes to be detected relatively cheaply. The model does not need to be the most intelligent model in the world. It only needs to meet the acceptance standards reliably enough to reduce the total cost of that production line. But the calculation changes when a plausible error is too expensive to discover, like legal claims, financial actions, medical interpretation, production infrastructure changes, board level recommendations, or research where one fabricated citation can damage your reputation. For these tasks, you may need a stronger model, expert human review, multiple checks, or all three. The decision rule is straightforward. Use cheaper models aggressively when failures are cheap to detect. Use them cautiously when a convincing mistake is expensive to discover. Run a real bake-off to test a Chinese model in your workflow. Choose one recurring job and collect approximately 10 to 20 real examples. Include ordinary cases, difficult cases, previous failures, messy inputs, and at least one example where the model should admit that it cannot safely finish. Then freeze the conditions. Give every candidate the same assignment, the same source material, the same tools, the same time limit, the same number of attempts, and the same acceptance standard. Before testing the models, test the validator. Give it one output you know is correct and one you know is wrong. The good output should pass and the bad output should fail. Otherwise, both models may appear successful simply because your checker is broken. Record the first attempt passes and passes after a retry and complete failure. Record the model and the tool costs. Record the human review time, the repair time, and the latency, and the exact endpoint that actually ran. Finally, read the failures. Did the model produce the wrong answer? Did it miss a source? Did the provider timeout? Did your system route the job incorrectly? Or did the validator reject some correct work? If you cannot identify clearly which part failed, you do not yet have a reliable verdict about the model. So, concluding the video, are Chinese AI models worth using? Absolutely. They are already serious specialists and challengers for bounded high volume work. But you don't select one because it is Chinese, open, or cheap per token. Test the exact model through the endpoint you will actually use on the work your business really performs. Measure first pass reliability, human review time, and the total cost per accepted result. If failures are cheap to detect, use these models aggressively. If a convincing mistake is expensive to discover, keep stronger intelligence and human judgment in the loop. So keep in mind, don't buy a country, don't buy a benchmark, buy a verified result. If you have learned something new today, give this video a thumbs up and subscribe this channel for more AI knowledge and information. And if you want to understand this entire evaluation process in detail, drop a comment and I will make another video for you. I'll see you in the next video. Bye bye.